Hey guys, welcome to the part 4 of getting started with k3s. Part 3, module 3. So in this module, we'll talk on the POS containers. We already know what containers are. We discussed in the last module, containers are, they are the C groups plus namespaces, or in another term, it's a isolated area on operating system with a resource usage limit applied on it. Yeah, so what are POS containers? So as we know, a pod has multiple containers. Pod is a collection of containers with a unique IP. Yeah, so one of the containers in that pod, which comes by default in every pod, is a POS container. So as we can see, there are 5 POS processes running, and equivalent, and there are 5 pods running. And we already saw in our last demo, there are 5 pods, there are 5 container instances, and there are 5 POS processes, and these POS processes are a child to those 5 pods. So here I'll just, for an experiment, we'll just try to create a deployment and see if there is a new POS container created and that parents to the pods container instance. So let's use kubectl explain deployment. You can use it, kubectl explain an API, Kubernetes API object. It will give you the little description on the API object, their version, and what are their like documentation on, little information on the API object and how to use it, what are the syntax. So let's create it. So as we know, to create there are 4 important directives. They are API version, kind, metadata, and spec. These are 4 things which every Kubernetes object carry. So here we are just like trying to create a hello hello deployment, which deploys a pod called hello, and then the sole purpose of this deployment is to check, as I already told, to check if there is a new POS container we created. Yeah, so just bear with me for this deployment.yaml file, and since I am in Vim, it's taking a little bit of time. So spec has, deployment actually deploys a replica set, and then replica set has replicas. They have selectors. So selectors is like you are going to select your pod and attach it with your deployment or replica set and manage the state. So we're just trying to put pod template. Pod template has metadata and spec. We just make sure that the label here we mention here is same as the label we mentioned in the deployment, in the mass label directory. So spec containers, so we'll just keep an image. We'll take an example image of Nginx, and we'll give a name called hello. There are a little more to add on POS containers. They are the first container to be created in a pod, and the last one to be destroyed. So when you are killing a container, when you are killing a pod, that the last one to be destroyed, ripped off, and the first one when you're creating it. So we are done with our deployment file. It took a lot of time since I did it in Vim, so many backspaces and front spaces. So let's see how it looks. Yeah, and examples of network namespaces it creates a IP stack, it creates a firewall rules and devices. So these are all for the containers inside a pod so that they can use it and share it. As you can see, we got a new POS container added with a PPID 12368 and a PID 12398. When we grep for that PPID, we can see there is a container instance which is attached to the newly created deployment object that is attached to the replica set, and that is attached to the container. Cool. So this proves our concepts. So here we can just go and describe and do so many other things. So I'm just trying to, yeah, when you can use describe for all the API objects. It will describe everything. So here you can see it gives you a set of events that happened. It also gives you the name, timestamp, annotation, selector, and there is something called min ready seconds. There is something, yeah, and what the main importance of this min ready seconds is, like, we can use this in productions and manipulate this value according to our use case. Suppose we have an use case that we want to delay our deployment of a container by 15 seconds. So we have five replicas, and we want to deploy on one and wait for 15 seconds and then deploy on the other. So this could be a good key value pair to play with. Yeah, and there is something called rolling update strategy. So by default there is rolling update strategy, and there is strategy tab. By default, deployment gives you a rolling update deployment strategy. Yeah, so now let's go inside a pod. So here I'm just trying to go kubectl exec. I was trying hello. So hello is a deployment name, not a pod name. So we just go get a pod name, clear it, and use kubectl exec minus it, I for interactive, t for terminal, give the pod name and -. I'm copying for SSL. So let's just do netstat minus plnt. Oops, not found. ps minus ef, not found. ps not found. Sorry, if ps minus ef is not found, ps will not be found. Let's go to etc host. vi not found. Oops, nothing is there. Let's do ping to the host name. Oh, it's all not there. So Nginx image does not contain any of these. Let's install ping. I think it's not the utility name. Let's do apt update. Yeah, apt update. Update is done. apt install nettools. This is for netstat and other networking tools. So netstat minus plnt. Now this should work. Yeah, this is working. So as you can see, there is an Nginx service running on port 80, but ping doesn't come under this package. There should be another package utility for ping. Oops, I should not try that ping again. I should use iputils ping or inetutils. There are two packages. You can use any of them. And install. So I missed. There was a copy paste mistake. So let's copy this, paste it, and there is again a spelling mistake. Sorry for so many spelling mistakes, guys. Yeah, now finally I think so I should be having ping working. Yeah, that is done. Clear ping. So what is that I'm trying to do is I'm trying to ping the host name and see if that is dissolving. So I could have tried with NSLOOKUP also, but yeah, I just also wanted to check the connectivity. So if you ping the host name, this is the pod name. So pod name is reachable to, resolvable to all the containers in a pod. How is that possible? That is possible with this entry in etc host file. So there is an IP and pod name entry. It is done when a pod is created. So if you want to verify what is the IP of a pod, you just do ifconfig, and then you can see that is the same IP. As I already said, its IP is a pod provides an identity to all the containers inside a pod. And yeah, the containers and how containers inside pods are uniquely identified with their port numbers. That's it for this module, guys. So yeah, if you go inside and check again, you can see there are two processes under same container instance as you can, as there is another process called nginx. So there are two containers. Yeah, that's it for this module, guys. See you next module. Stay home, stay safe. Bye. Hey guys, welcome to the part 4 of getting